Hi, welcome back. So today we will discuss this particular past year paper that is on S2. So question 1, the height of a certain species of deer known to have a standard deviation of 0.35. You take a random sample 150 and then the mean height is 1.42. So you need to calculate the 96% confidence interval. So this is obviously sample mean. So the mean is 1.42 and then your population standard deviation is 0.35. Number of sample is 150. So in order for you to calculate the confidence interval, you need to figure out the value of C first. So you start by finding the probability of Z between minus C to C, and that is 0.96. So this goes back to Pz smaller or equals to C minus 1 equals to 0.96. So when you substitute, when you move all the things around, in the end you get 0.98. So check from your table, your C should be 2.056. C should be 2.054. So once you find your value of C, the 96% confidence interval would be your X bar plus or minus C multiplied with your population standard deviation divided by the square root of 150. So this is 1.42 plus or minus 2.054 times 0.35 divided by the square root of 150. So this will be 1.36, 1.48. Part B. 96% of deer of this species are likely to have heights that are within this confidence interval, whether or not she's correct. Answer is no, because the confidence interval is about the mean of a sample and this does not mean that if you take the whole population, for example, 96% will have heights within this confidence interval. So that's the answer. It's just a 1 mark question. Question 2. You have masses of small and large bags, and then find the probability of total mass of 3 random small bags is greater than 1 randomly large bag. So you need to be careful about this wording, because this means you choose 3 small bags randomly. So this is not 3 times, let's say S as a small bag, but this is equals to 3 randomly chosen variable, S1 plus S2 plus S3. So let's say S represents a small bag. It is a normal distributed with 16 kg, and then 0.4 as your variance. So L is the large bag. So this is 51, 0.9. So the probability of this is a probability that you need to find. 3 randomly chosen small peg is larger than 1 large peg. Or you can rewrite as P S1 plus S2 plus S3 minus L greater than 0. So you can define a new random variable which is also normally distributed. So this new variable is S1 plus S2 plus S3 minus L. And this new variable is normally distributed. So because you are not taking 3S, you are taking S1 plus S2 plus S3, remember that your mean should be 16 plus 16 plus 16, and then minus L, which is 51. So for the variance, that will be 0.4 plus 0.4 plus 0.4. For variance, the minus become plus, so this is plus 0.9. So this is the same as minus 3, 2.1. If you use 3s, over here basically this will become 9 times 0.4, which is wrong. So you need to be careful about the question. So once you found the expected value and the variance, the above probability will become x greater than 0. So in this case, you can change it to z-score greater than 0 minus 3 is 3. Perhaps I can write, 0 minus 3 divided by the square root of 2.1. So this is Pz greater than 2.07. Or you change it here so that you can read from the table. So this is 1 minus 0.989808. So the final answer is 0.0192. Question 3. Times taken by a random sample of 75 students to complete a test were noted. So you have sum of t and sum of t squared. Calculate the unbiased estimate of population mean. So population mean would be just sum of t divided by 75. So 230 divided by 75. So this is 3.07. The unbiased estimate of variance will be 1 over 74. Sorry, not 5. Times 930 minus n, which is 75, times 3.07 squared. Calculate everything, you get 3.04. So that's part A. Part B. You should now assume that your estimate from part A to be the true values of the population mean. Time taken by another random sample of 75 students noted. Sample mean was found. Find the value of A such that the sample mean is greater than 0.234. So just write down the information first. So these two values are regarded as your population mean and population standard deviation. So this should be squared because that is the variance. Okay. So now what you need to do is to find the expected value of t bar. It is of course the same as 3.07. The standard deviation of t bar would be the square root of 3.04 divided by 75. So this should be 0.201. So you need to find PT bar greater than A, 0.234. You first find the corresponding Z score. So this is the same as, for example, this particular probability, and you need to convert it. So the reason why you need to convert is because, let's say this is your probability distribution. 0.234 is smaller than 0.5, so it means that your A prime has to be here, and you are studying this area. So this is the same as 1 minus pz smaller than A prime, 0.234. So pz smaller than A prime would be 0.766. So your Z score in the end is 0.726. So then finally you have A minus 3.07, the mean, and then divide by 0.201 is equals to 0.726. So calculate everything, A should be 3.22. Okay? Question 4. Show that A is given by that. So essentially you need to integrate from 2 to 3, ax power minus 2 minus 18 power x power minus 3 dx. This has to be equals to 1. So the integration will give you minus ax minus 1 plus 9 x minus 2. Substitute the value of 3 and 2 inside. This has to be equals to 1. So you have minus a over 3 plus 1 plus a over 2 minus 9 over 4. This is equals to 1. So finally A, when you calculate everything, because there are two very similar symbols, one is A, one is 9. So perhaps I write carefully. So this is A over 6 equals to 9 over 4. So A will be 27 over 2. Part B, show that the expected value is given by that. So integrate from 2 to 3, 27 over 2. So remember that your fx you have to multiply with x. So initially you have x power minus 2. So now it becomes x power minus 1 minus 18 x minus 2 dx. So this is 27 over 2 ln x plus 18 x power minus 1. Substitute the value of 2 and 3 inside. So this will become, 27 over 2. Ln 3 plus 6 minus 27 over 2. Ln 2 minus 9. So you can just group the ln 3 and ln 2 together by by division because of the minus sign. So in the end you have 27 over 2 ln 3 over 2 minus 3. Question 5. The length of a certain worm is normally distributed by mean, mu, and standard deviation 2.3. article states that the mu is 12.7. You wish to test whether this value is correct or not. So you measure a random sample of 50 worms. Sum of x is 597.1. Carry out the test whether the true value is different from 12.7. So this tells you you should use a two-tilt test. Because you want, probably not you, the scientist, wants to check if the value of mu is different from 12.7. So now carry out the test. So first, list down your null hypothesis. Mu is 12.7. Your alternative hypothesis is your mu is not 12.7. The significance level is 0.01, but because this is a two-tilt test, so you need to divide by 2. So now you need to find out what is the value of your x as a normal distribution. So this is 597.1 divided by 50 sample, which is 11.942. Second one, 2.3 squared divided by 50, which is 0.1058. So you have two tests. The first one being the right side. Test whether or not your mu is greater than 12.7. So you just convert this particular value into your z-score. So this is pz greater than 2.330. So you want to read from the table, so you need to do the conversion. So in the end, you find that this is the value, and this value is greater than 0.005. So the second test you need to do is the other direction. So this time you already calculated the z-score above, so you can directly just write it down, and this is also greater than 0.005. So there is no reason to reject your null hypothesis. Hence, accept H naught. So that's the whole test. Question 6. Number of customers arriving at certain tests A and B during a 10-minute period are given by the Poisson distribution. Find the probability that a randomly chosen 15-minute period. So the time period is different, so you need to be careful. So A is PO 1.8. This is for 10 minutes. So for 15 minutes, A would be given by 1.8 times 15 divided by 10. So that will be 2.7. So now you need to find PA more than 2 customer. That will be equals to 1 minus PA smaller or equals to 2. So you break it down. So once you break it down, in the end you can use the formula. So this is E minus 2.7 times 1 minus E minus 2.7. So this is multiplied with 2.7. Then 2.7 2.7 squared divided by 2 factorial. So in the end, you should get 0.506. Find the probability randomly chosen 5 minutes. Both deaths is less than 4. So this time you need to convert your A accordingly. So this is PO 0.9. Your B is 2.1 times 5 divided by 10. So this is PO 1.05. So you need to, let's say, denote A equals to A, X equals to A plus B. So your Poisson distribution would be just adding them together, 1.95. So Px has to be smaller than 4. So this will be Px equals to 0, x equals to 1, x equals to 2, x equals to 3. So here I factorize out all the e to the power of minus 1.95. So the first term is 1, second term is 1.95, third term is 1.95 squared divided by 2 factorial, and then 1.95 cubed divided by 3 factorial. So in the end you should get around 0.866. Part C. She wants to wait long enough to be 90% certain seeing at least one customer. Find the minimum time she should wait. Minimum time she should wait. So in this case, it is better for you to do it this way. So this is test B. It has to be at least 1 greater or equals to 1. So because in the end you need to find the so in the end you need to find the minimum time. So it's better if you write greater or equals to 0.9. So over here, the left side, this is 1 minus PB equals to 0. And you slowly break it down. Okay. So PB equals to 0 will be e to the power of minus lambda. So in this case, because you need to find the time, so you don't actually know what is the time interval in this case. So the initial Poisson distribution is given during the 10-minute period, so you need to do the conversion later on. So right now, what you need to do is to find the value of your mean first. So by the formula, so this is the formula for Poisson distribution. So because your b equals to 0, so this particular term equals to 1. So that's why when I write over here, this is just e to the power of minus lambda. So the sign changed accordingly, 0.1. So you take the natural logarithm. Okay, so ln e equals to 1. And then you change the minus sign. So you get something like this. So in the end, when you find what is the value of ln 0.1 and then multiply with minus 1, you get 2.3. So now let's do some ratio. So if you have 2.1, it takes you 10 minute periods. So if it is 2.3, so what is the period of time? So then you can just calculate x is actually 2.3 divided by 2.1 times 10 minutes. So this is 10.95 minutes. So because of this particular symbol, you need to find the minimum time. So 2.3 corresponds to 10.95 minutes. Therefore, the minimum time should be 10.95, or you can round up to 11 minutes. So that will be our answer. Question 7. Number of accidents per year on a certain road has this Poisson distribution. In the past, the value of lambda is 3.3. Recently, there is a new speed limit imposed, and the council wish to check if lambda has decreased. You have a total number x during 2 randomly chosen years. So this you need to be careful because the lambda over here is for 1 year. Alright. The test is 5% significant level. Calculate the probability of type 1 error. So type 1 error basically is the probability of rejecting your null hypothesis given that your hash knot is true. So in this case, what you need to do is basically so your lambda has decreased. So it means that from your distribution perspective, let's say this is your critical value, this is a critical region. So your critical region is exactly your type 1 error's probability. So then let's test it out. So for 2 years, your Poisson distribution will be 2 times 3.3, which is 6.6. Alright. So you need to test the values one by one so that you can identify the critical region. So let's test px equals to 0. This is just e to the power of minus 6.6. if it is equals to 1, this is 0.0090. If it is 2, this would be 296. If it is 3, this will be given by here. So when do you need to stop doing all this process? Because you are testing 5% significance level, so this is obviously greater than 0.05. So you can just stop here. Then you do the sum. So you know for sure that this is greater than 0.05. So you definitely need to stop at x equals to 3, so you can test this out. You sum 0, 1 and 2 together, you find that this is 0.04, which is smaller than 0.05. And when you sum with x equals to 3, definitely it will be more than 0.05. So therefore, you know that x equals to 2 is your critical value. And therefore, the probability of type 1 error is 0.04. Given that x equals to 2, carry out the test. So your null hypothesis is that your lambda is 6.6. Alternative hypothesis is it has decreased. So x equals to 2. We previously calculated this thing is 0.04, which is smaller than 0.05. This is a one-tailed test because you want to test whether or not it decreases. Therefore, we have enough evidence to reject the null hypothesis. Part C. Council decides to carry out another similar test at 5% significance level. The true value is 0.6. So this is for 1 year. You need to take note. Calculate the probability of a type 2 error. So what is a type 2 error? So type 2 error is the probability of accepting your null hypothesis, provided that it is a false statement. So previously I mentioned that for type 2 errors, usually they will give you what is called the true statistics. So in this case, the true statistics for 1 year is lambda equals to 0.6. So for 2 years, this will be 1.2. So what is your type 2 error? Basically, it will be, so previously we calculated the critical value. So for type 1 error, you just calculate the critical region, the area of the critical region. For type 2 error, you use the true statistics to calculate this particular region. So what you need to do is to calculate this thing, because in the previous section we already identified that x equals to 2 is your critical value. So if let's say you want to calculate the critical region, you need to use px smaller or equals to 2, meaning that the other side will be px greater than 2. So that's the rationale. So this is just 1 minus px smaller or equals to 2. So now you just calculate px equals to 0, x equals to 1, x equals to 2. And when you do the calculation, use the true statistics. So this is 1 minus e to the power of minus 1.2. So the first term is 1, the second term would be 1.2, the third term is 1.2 squared divided by 2 factorial. So this is 1 minus 0.3012, 3614, 2169. So this is 1205. Part D. Using lambda equals to 0.6 and a suitable approximating distribution. So in 30 years. So this is for 1 year. So for 30 years, your x would be 0.6 times 30, which is 18. So you need to approximate. 18 is greater than 15, so you basically approximate using normal distribution. So because this is a discrete random variable approximated to normal, which is a continuous random variable, remember when you calculate your probability later on, you have to account for that continuity correction. So this is a normal distribution, 18, 18. So you need to find the probability of more than 10. So there's no equal sign. So when you calculate the z-score, the continuity correction requires you to use 10.5. The mean is 18. Standard deviation is square root of 18. So this is pz greater than minus 1.768. Or this is the same as pz smaller than 1.768. So read from the table, this is 9615. Okay, that's all for this particular paper. Thank you.